Corporate finance practice problem using OneNote. Use annuity calculation to find payment amount. Get ready. It's time to take your chance with corporate finance. Here we are in OneNote. If you have access to OneNote and would like to follow along, you're not required to, but if you have access and would like to, we're going to be in the tab on the left-hand side. We're in the practice problem area and down in section 945, use annuity calculation to find payment amount. Also note, when using OneNote, you might want to look at the immersive reader. Many of our presentations will also be duplicated in the text areas down below. Text areas being, in essence, transcripts which can be translated into multiple different languages and both read and heard in multiple different languages, thereby being a good complement to the presentations. Going to be closing this back out. We're going to have our information then up top. We'll go through the calculations of that information on down below. So now we have a common kind of investment type of scenario where we will be utilizing the present value of an annuity calculation. We have an amount that we're saying 500,000, the life expectancy is 25 years, and the rate is 10%. So question then, 500,000 we have, if I put that into an annuity at the rate of 10%, how much would I get then in return for the next 25 years in terms of payments? We're looking then for the payment amount. Note that this is a little bit different than an annuity type of situation where we're thinking about us putting money into an annuity, having the interest rate and number of periods, and then trying to figure out the present value. So that's what the present value calculation normally would be solved for. We would be solving for the present value, which would be the stream of annuity payments. But in this case, of course, we're looking for the payment. We already know the end amount of the formula, that being the 500,000. That's what we want to put in for 25 years, and the rate in order to solve for how much we would get back in terms of the payment. So we're going to be basically using that present value calculation, solving for an unknown that isn't the end result present value, but using the same formula. In other words, we're solving for P in this formula, and instead of course, learning or memorizing a whole new formula algebraically, we will simply plug in what we know using the present value formula, solve then for P. So algebraically, it would look something like this. We would have the 500,000 equals P, unknown, 1 minus 1 plus R, which would be 10% to the negative n, negative 25, over R, which would be 10%. Then having only one unknown, we can then solve algebraically for P. So in a book problem, that would be the most likely way that you would go about and solve this type of problem. However, in practice, most likely you would be using something like a function down here, the Excel function, and you might say, I'd want to use the present value function down here, but the end result is not what I'm looking for. Do I need a whole nother function? Because what I want is this item here, the payment amount. And so can I use this same function in order to back into that amount, knowing that I have only one unknown? I can't do it algebraically, but I can use a trial and error kind of method using goal-seek. Goal-seek then basically allowing us to apply the algebra without doing a whole nother kind of equation, in the sense that it'll do it in basically a trial and error type of method to find an unknown other than the end result of the problem. So let's go ahead and think about that scenario. So first scenario, book problem, you'd be doing the algebra. Second scenario, we're going to first start off thinking about putting this equation into our basically Excel worksheet, which we will imagine being all linked together with formulas, and then think about how the goal-seek kind of function could help us out with that formulaically, and then go to our function and apply the same concept there. So if I put this into our Excel worksheet, it's going to be P times this whole thing. P is going to be on the... Now the payment up top is the amount that we wouldn't know here. This would be the unknown, and I'm going to have to plug that in. I'm not going to rework my equation down here. I'm going to put it in the same format, using the same function, same format of the equation, and I'm just going to plug something in here. So this is going to be the answer here, but this yellow item, we would put just something there, not 0, because if there's some kind of thing that you need to divide by 0, for example, it could throw off the problem. So I'd put something in there, and note that I'm going to go in there and adjust that using the goal of goal-seek after we connect everything up, something like 10,000 for a starting point. Then we're going to say that we have 1 minus 1 plus r to the n. I'm going to put the 1 in its own category here, then pull out the 1 plus r to the n in the inner column. So there's the 1, The rate is 10%, 1 plus 10%, or 100% plus 10% is 110% to the negative n number of periods in years, in our case, that being 25. So if I take the 110% to the power of 25, or negative 25, I should say, we then get this 0.092296 and so on. Now that would be the entire numerator. If we take that and, that would be this whole amount right here, 1 plus r to the negative n. Now we're going to take 1 minus that amount. So 1 minus that amount gives us the 0.90770400. And now that is the numerator divided by the denominator, which is r, 10%. Numerator divided by the denominator gives us the 9.07704 and so on. And so now we've got these two amounts. We could simply multiply them out. Now this one again would be the unknown. If it was 10,000, of course, we would come out to something, different, something that would be wrong. If this is going to be the correct answer times this gives us the 500,000. And that's our end result up top. Now, if this was something other than the 5584, and this didn't come out to the correct answer, I know what the end result could be. So instead of reworking the spreadsheet algebraically to solve for something else, in this case, in order to solve for the payment, we can simply use trial and error up top and start saying, well, what if it was 20,000? What if it was 30,000? What then would the end result be? Doing this manually with a calculator would be very tedious. But if you have this in Excel, that's not quite as tedious to do that. And then you could use basically goal seek, which would in essence do that really quickly. The computer would basically do that. So you can have your same worksheet here, tell Excel, hey, look, I want this bottom line number to be what I know it should be, the 500,000, by changing this number. And that's how you can basically solve for one unknown in a spreadsheet type of format without reworking it algebraically. You can use the trial and error type of method. That is useful. That concept is useful because we would do the same thing basically down here with the function, which in practice is more likely what you would be using. In other words, to solve for this, I would say, hey, look, I'm not going to look for, just like algebraically, I'm not going to look for another equation to figure this out. I'm not going to memorize another equation. And down here, same thing. I'm just going to plug in the unknown and then solve for it. Same thing down here. It's like, well, I know this function, very common function, the present value function. I know there's only one unknown with regards to that function. Can I use this same function in order to work this problem, even though the unknown in this case isn't the present value, but the payments? And we could use the same method. What we're going to do is put the payment down here. So this would be the payment amount that we would guess. And we'd start off with something like 10,000 in it or something like that, and something other than 0. And then we put in our formula, which would be the present value of the rate, which we know is 10%, comma, the number of periods we know is 25, and then comma, the payments, which we don't know, which we can plug into some other cell, plugging in some other random numbers, such as like 10,000 as a starting point, and then let Excel calculate the end result, which we know what the end result should be. It should be 500,000. If we get something other than 500,000, which we would if we were guessing, then we can just basically change this cell. We can do it manually. We could start to change this cell, and because it's connected by the formula, it'll change the end result as we get closer and closer to what we need it to be, the 500,000. And then we could, of course, use Excel if we want to do that for us. We could say, hey, Excel, would you set this cell to be 500,000 by changing this cell, and Excel will basically do that trial and error function for us automatically. So in that way, we can kind of use these functions in a similar way as you would use them algebraically, meaning I can use the same function to solve for any unknown by simply basically using goal seek to figure out the unknown component, instead of trying to find a whole nother function that would be solving for the payment, which would be possibly there, most likely, you could find that, but it's much less common of a formula that would be used than the just present value calculation. You can also do this with the tables. This is something that you might not see in practice as much, but it's something that you could see in a book problem quite possibly. So what we know is the rate, we know the years, and so we could then find the interest amount, and we know the end result. So in other words, I can look on the table. I have what I need to find the table. So 25 and 10%. So we look for 10 and 25 down here, 10 and 25. We get the 9.077, and that's going to be this 9.077. So what we know then, we don't know this top number. We know the 9.077, and we know what the end result should be, that 500,000. Normally, we know this number, and we multiply them out. If we don't know the top number, but we know the bottom two numbers, then we can take then the 500,000 divided by what we got from the table, 9.007, and that's going to give us our 55, 5, 12, 38, about